Dear students, question number 21 says that the power dissipated in the resistance R in this circuit as shown in the figure is maximum if R is equal to. Now dear students, a circuit has been given to us. To proceed with this question, let us try to find out the equivalent battery of this battery combination. We can see that these two batteries are in series, so they both can be combined into a battery of net EMF 4 volts, that is 2 plus 2, and the net internal resistance of 10 plus 10, that is 20 ohms. Now dear students, this particular battery and the battery with potential 4 volts and internal resistance 40 ohms can be considered to be in parallel. So the net equivalent battery EMF and the net resistance of the battery can be calculated using these formulas. That equivalent E will be equal to summation of individual EMFs divided by individual internal resistances divided by 1 by Ri. And the equivalent internal resistance can be calculated as 1 by R1 plus 1 by R2 whole to the power minus 1. Now R1 here is 20 ohms and R2 is 40 ohms. So R equivalent can be written as 20 into 40 by 20 plus 40, that is equal to 80 by 6 or 40 divided by 3 ohms. Now dear students, from the concept of maximum power transfer, we know that when the resistance of the external load is equal to the internal resistance of the battery, then the power dissipated through the external load is maximum. Therefore, for the maximum power, the value of R should also be equal to 40 by 3 ohms. So the correct answer for this particular question should be option number 1. Now dear students, let us proceed to the next question, which is question number 22. Dear students, the question number 22 is based on the concept of potentiometer. The question says that a potentiometer circuit with potentiometer wire 10 meter long and an ideal main battery of EMF 8 volt has been set up for finding internal resistance of a given cell. When the resistance R connected across the given cell has values infinity and 10 ohms, the balancing lengths on the potentiometer wire are found to be 2.4 meter and X respectively. If the internal resistance of the cell is 2 ohms, then the value of X is. Now dear students, we know that the internal resistance of the cell small r can be related to the external resistance connected across the cell capital R by a formula that small r is equal to capital R multiplied by L1 by L2 minus 1, where L1 is the balancing length when capital R is equal to infinity. Therefore L1 as per the question is equal to 2.4 meters, where L2 is the balancing length when the value of capital R is as per the question. Therefore L2 is equal to X. R has been given to us to be equal to 10 ohms, whereas small r has been given to us to be equal to 2 ohms. Dear students, if we substitute these values in this formula, we get 2 to be equal to 10 multiplied by 2.4 divided by X minus 1. Solving this equation, we can find out X to be equal to 2 meters. So therefore, the correct answer for this particular question should be option number 3. Dear students, now let us proceed to the next question, that is question number 23. The question number 23 is based on the concepts of voltmeters and ammeters. The question says that an ideal voltmeter V and an ideal ammeter A are connected in a circuit as shown in the figure. If the reading of the voltmeter is 32 volts, then the reading of the ammeter will be. Now dear students, we know that in a circuit when two elements are connected in parallel, the potential difference across the elements is same. For example, in this circuit, this voltmeter and this 8 ohm resistance along with the ammeter are in parallel. As per the question, the potential difference across the voltmeter is equal to 32 volts. Similarly, the potential difference across this arm should also be equal to 32 volts. Now, since the ammeter is ideal, which means that the resistance of the ammeter is 0, we can easily assume that the potential drop of 32 volt would be all across the 8 ohm resistance only. Let us assume that a current I flows through this 8 ohm resistance. Then we can write that I into 8 from the formula IR should be equal to 32. Therefore, I should be equal to 4 amperes. Dear students, therefore, the correct answer for this particular question should be option number 1. Now, let us proceed to the next question, that is question number 24. Dear students, the question number 24 says that force between two conducting large plates with charges plus Q and plus Q by 2 as shown in the figure is. It is given that the area of each face of the plate is equal to A. Now dear students, force between any two plates can be written as charge on one plate multiplied by electric field due to second plate. Let us assume that this is the first plate and this is the second plate. Now, electric field due to any plate is equal to Q by 2A epsilon naught. Now, since we are trying to find out the electric field due to the second plate, that is E2, the charge on the second plate is given as per the question equal to Q. So we substitute Q here. The area is given to be equal to A. So A has been substituted here. So this is the final result for the electric field due to plate 2. Now the force should be equal to the charge on the first plate, which is equal to Q by 2 multiplied by electric field of the second plate. Now the electric field of the second plate is equal to Q by 2A epsilon naught. So therefore force can be written to be equal to Q square divided by 4A epsilon naught. Now dear students, therefore the correct answer for this particular question should be option number 1. Now let us proceed to the next question. The next question, which is question number 25. Dear students, the question number 25 says that for an electric field E vector present inside a metallic conductor, option 1, the electrons move rectilinearly in direction of E. Option 2, the electrons move rectilinearly opposite to E. Option 3, the electrons move randomly but slowly drift in direction of E. Or option number 4, the electrons move randomly but slowly drift in the direction opposite to E. Now dear students, in a conductor, as the electrons move inside the conductor in presence of an electric field, we know that they still have their random motions. But since these random motions are so randomly oriented that their net average turns out to be 0, the only effect that is on an average visible is due to the drift of the electrons. Now, since the force on electrons is in the direction opposite to the E, the electrons in totality or on an average slowly drift in the direction opposite to E. So dear students, the correct answer or concept of this problem is that the electrons move randomly inside the conductor but slowly drift in the direction opposite to E. So the correct answer should be option number 4. Now dear students, let us proceed to the next question, which is question number 26.